Hello everyone. Today we're going to take on a new topic called rational functions. Now this lesson is likely the most abstract lesson of the year. However, with a few key points, it is fairly manageable. But let's start investigating, and this is the purpose of this video is just to simply to give you an idea of what's coming on. If you want, I would instruct you to have a piece of paper beside you to work out a table of values. Otherwise, just sit back and enjoy the next 7, 8, 12, 19 minutes. So I'm going to graph the function y is equal to 1 over x minus 2. And we may recognize that x cannot be equal to 2. That is a non-permissible value. So the first thing I'm going to do is I'm going to pick an x value. So if x is equal to 0, what is the y value? Well, the y value is negative half. So I'm simply going to draw a point right there. Maybe I'm going to say, well, when x is equal to 1, what is the y value? What we see is 1 divided by negative 1, we see our y value is negative 1. Now that's curious. Now I'm also curious when x is equal to 2. Okay, please don't do that because x cannot be equal to 2. Right? 1 divided by 0 is not a thing. However, x is equal to 3. X is equal to 3, that's 1 over 3 minus 2, so 1 over 1, which is 1. The y value is 1. We end up 0.31. And maybe just out of curiosity, x is equal to 5. The resulting y value is a third. Maybe I'm going to go x is equal to 6. The resulting y value is a quarter. Now this is not making too much sense. Now I'm just going to go maybe x is equal to negative 2. The y value is negative quarter. I've never seen a function like that. So maybe a curiosity striking me here. Maybe, just maybe, I'm going to try to go to close to 2. So y is equal to 2.2, for instance. Wow. Sorry, the x value is equal to 2.2. It goes up there. Now, on the other side of 2, which is a very strange concept, but like x is equal to 1.7 or something. Oh, it's down there. So, this is quite puzzling. So, never seen anything like it. But the most important characteristics of a rational functions are something called asymptotes. Asymptotes are imaginary lines that are used as guidelines to graphing the function. And in fact, those are my asymptotes. So I have a horizontal asymptote, y is equal to 0. A vertical asymptote, x is equal to 2. That's what they look like. These are going to be my guidelines for drawing, and it's going to take us 2 days to really dissect this, but that's the resulting function. Now that was kind of a surprise. So in reality, if we wanted to graph this function, probably be so much better to do it like, so. So actually identify your horizontal and vertical asymptotes magically somehow. That's what we're going to be studying. Take points and graph them and use those guidelines in a meaningful way later on to make our graph. Let's take a look at our second function. I know that was really abstract, but I'm trying to drive home a point here that we'll get to. Now, here, y is equal to 4 over x squared plus 1. Notice that this function, the domain of this function is x's element of the reals. There are no restrictions. There's no non-permissible values. I don't know what this function is going to look like, so I'm just going to plug in values. So for instance, if x is equal to 0, the output is 4. When x is equal to 1, the output is 2. When x is equal to 4, the output is, if x is equal to 4, the output would be 4 over 17, which is almost a quarter. So that's kind of hard. So maybe I want to see what happens on the other side of the x-axis. When x is equal to negative 1, Right, negative 1 squared is 1, 1 plus 1, and the denominator is 2. We get a y output of 2. There we have it. So for this one, I get my horizontal asymptote of y is equal to 0 by my definitions that we're going to look at, and then I'm just going to use that as a guideline magically somehow, and this is my function. Last example. This one is the most complicated one. So I'm just going to tell you right off the hop here that I have a horizontal and vertical asymptote, or horizontal asymptote at y is equal to 1. So I'm going to draw that even before. So magically, this algebraic form tells me my horizontal asymptote. It also tells me my vertical asymptotes. Now, if I may ask you, what are my non-permissible values of this expression? My MPVs are going to be x cannot be equal to negative 2 or positive 2, which incidentally are vertical and horizontal asymptotes. That's mostly the case, but not always the case. So now I am just going to graph some points. So 0, 0, I plug that in. I end up with x is equal to 0, y is equal to 0. I'm going to plug in other points randomly here and there. Using a table of values, I can figure these out. And it looks like just random points. If I get rid of my horizontal and vertical asymptotes, it looks like random points. Yet, once I put my vertical and horizontal asymptotes on there, and my function's really broken up into 3 different domains. My first domain would be right here. My second domain is the domain in the middle between those 2 vertical asymptotes. My third domain is over here. So I'm just going to click the button and see what happens here. That's what my graph looks like. So over the next little while, I guess 2-3 days, we are going to be graphing rational functions. What are the keys to graphing rational functions? Well, we're going to uncover them over the next few days. The keys to graphing rational functions are number 1, identifying horizontal and vertical asymptotes. Number 2, understand the definitions of a vertical and horizontal asymptote, which is quite difficult actually. 3, apply the characteristics to vertical and horizontal asymptotes. And then basically, we just use a table of values to figure out points. Connect the dots, and we're done.